Stuart here. Today a really short video on some common gaps in problems you may run into in DDD, and just a couple of useful patterns and observations that I found helpful when I'm trying to work through these things. We'll have a series of these as I come through and look at cases as I deliver software to various customers, or I work on open source projects or do analysis projects on my own or with a team of open source folks. I guess what I am trying to say at the bottom line is DDD isn't this hyper prescriptive, you learn it and learn it and learn it, and then every problem has a solution and everything is easy. Because the real world's not easy, and no analysis, no process is going to result in things being super crisp. And what we shoot for is Pareto, right? With, the 20% that solves the 80%. And we want to look at the implementation in reality of our domain-driven design through the lens of solid, because we're going to have to implement what we're doing at some point. And when we implement anything, solid is an extra good way of looking at things. The other thing is that people sometimes say DDD and microservices in the same breath. And you could make microservices without doing DDD first. I'll stipulate that isn't a good idea for anything super complicated. If you have, essentially a single domain and you're making a microservice for it, it's probably okay. But more and more complicated systems with lots of interactions, anytime you get past about 3 to 5 fundamental core entities or roots, as they're called in DDD, you probably ought to finish doing the DDD before you try to implement anything. And, the other thing is that sometimes microservices aren't the best way to implement things because they cause interesting challenges. And sometimes the overhead of solving those challenges is more costly than combining or conflating the domains. And I'll point out something pretty important. And that is, just because a bunch of things are in different domains and there are shared contexts and there are, and you build code around that, right? You build libraries, you build all sorts of things. That doesn't mean that stuff can't run in a single runtime context. A nice example of that is there was a point in time in Kubernetes that it was pretty microservice-y. But what they discovered is that the performance overhead and the memory footprint and the CPU footprint and all the other resource usage was not anywhere near as efficient as it could be. And so they took those concerns and they folded them into what effectively is a monolith, a single executable that runs in a single process. And yes, there are threads and, whatever. But the idea is that for inter-domain communication, and that's the place where things get expensive, I'm just going to stipulate now, anytime you've got a line that goes from one domain to another, that's where the expense is. For some things, like the Kubernetes core, whether it's the kubelet running in a container host, or whether or not it's the Kubernetes backplane running, high availability on a cluster. The wire is always the most expensive thing, even if the wire is reflected onto the same host. So, even if you have two APIs that are on the same host, that process boundary crossing is not free. Generally speaking, for a lot of traditional APIs, it's north of 80 milliseconds. You can grind that down with gRPC and some other tricks and grind it down and grind it down and grind it down and get it to 40 milliseconds. But again, it's not free. And so sometimes the implementation as a monolith is not a terrible idea. Now, for most business systems, that's not true, right? That tends to be more true for systems programming. But it is something that you should think about. So here's a use case that happens all the time. And I'm just going to pick on the old and tired, order and customer set of domains This is sort of in stewardese. This is how I think about things. I do tend to put APIs and event handlers and queues and events and things like that into my models because I want to know what the interaction is going to feel like. And I often will go through the business use cases, like I've got a new customer who's joining us for the first time. They've carted up their first cart. They've gone through checkout. We've generated an order, at the business tier, right, with customer information as part of that. And now I want to see how, that's going to flow through all my domains and things. And so I like having some of these sort of non-traditional DDD things embedded in my DDD model because I want to see how I would go about reifying it. And I want to make an honest to goodness real eyeball that says, well, what about this? What about that? So let's talk about this model for a second. We have a customer context, and, it's the parent of customer. Customer derives from customer context. And a customer represents a customer, and it's in a shared context because multiple domains may need to have a shared idea of what the customer context or customer is. Customer is going to be a big fat record with lots of stuff in it. Customer context is going to be just enough information for other domains besides the customer domain to have enough information that they don't necessarily have to fall back and call the customer API to get those details. There are certain reuse details that we might want all the time that would belong in a context object. And typically what happens is you develop the customer object and then you realize that you need a subset of the fields in a bunch of different places. And then you say, well, I'm going to extract out a set of these fields without methods typically as a context object. And so that's kind of the thing about that. And obviously customer, derives customer, and iContext derives customer context. It's useful to have those interfaces in the same way it's useful to have an iRepository. I like the repository pattern. I'm comfortable with it. I like to separate my entities from the actions on those entities. I think it's easier to maintain as well. And it allows a certain amount of abstraction because it keeps the repository from knowing about customer other than its reference to the customer object. So if you're in a high-level language like TypeScript or C# or Java or anything else that supports classes and object-oriented programming, that it's useful to not have customer have the repository stuff on the inside. It also allows you to then fake customer repository in unit tests, right? Because you can make a faker object that is, a no-op or an in-memory database or something. And the real customer repository would have an iRepository pluggable thing into whatever the backend storage is. It's also useful whenever you have a repository to just assume that you want to expose a change event. And if it has no subscribers, it has no subscribers. Fine. But it's rare that I will have any kind of repository pattern unless it's something that's completely shielded from the other domains. And even then, if the entity that the repository is for can be accessed via a public API on that domain, in this case, the customer API, I almost always provide a change event out of the box. Because even if I don't need it right this very second, it's been my life experience that at some point somebody is going to want to be told that there was an operation on the customer API that caused the customer repository to update the data in the store. And it's useful to have that as a push instead of a continuous pull. So, that's the right side explain. The left side explain is that I tend to make events write durable queues. So I do a lot of work in Azure. I love Azure Service Bus, but if you've got another good one, Kafka or Rabbit or whatever, it doesn't matter. But a durable queue is defined as if I write to it, when my call returns, I'm guaranteed that message won't get lost, right? Up to some SLA, obviously. And if I read from it, I can read from it using the lease pattern. And I have other videos on that. So that if my consumer, my message consumer, crashes or is stopped or whatever, that I'm not going to lose that unit of work that's represented by that message. Now, in the case of change event messages, typically what you do is you tune the time to live on the message to balance the overall SLA of your service tier. So, because if absolutely no one cares about the message after a certain amount of time, and typically I am loath to go less than 24 hours. In most enterprise systems, there isn't much of a price associated with that. It's trivial compared to the insurance. So if something is down, like over a weekend or on a holiday or something, I don't lose all my change messages. In some extreme cases, I actually write a little worker off to the side that lives in the customer domain that from the date timestamp of a particular time, like an outage, that it will go and ping the customer repository using the match operator and regenerate the customer change events. And in systems like that, I make sure that my customer change worker, which is in the domain of order, is reentrant. In other words, if it sees the same event for the same entity, it doesn't matter if it reprocesses or it's smart enough not to reprocess it. But generally, not caring if it gets reprocessed is much better. So, what's going into the body of the message is the customer context, the minimum number of shared fields that makes it possible for order to do its work without having to care about it much. And the important thing is that, the customer change process keeps the customer cache up to date. And I can, the consumers of the cache can fetch, or store, or delete. In the case of the customer changes, we deleted the customer, which should be rare because it has a knock-on effect on the orders. But deleting a customer might soft delete the customer and then cause all the orders that are in flight, that are undelivered, to be canceled and returned to sender. So, that's why you'd want to know about deleted ones. And then if things really go pear-shaped, right, you may want to just clear the cache and again use a little change engine in the customer domain to regenerate all the events from a date and time, which again re-intersects with time to live, right? Because at the most, I don't want anything that's changed since before my time to live expired. So if my time to live is 24 hours or 48 hours, I generally want to go back 24 or 48 hours. And I want to start with a clean start to minimize the number of messages. So in addition to clearing the cache, I'm going to clear the message queue as well. So there's a little subtlety there before I start the robot going to regenerate. So in the case of an order, right, I get an order for example, a new customer, and I've got to do a bunch of business logic to do the order. But the other thing is that I want to tell the customer subsystem that if the customer's updated its data or is just plain spanking new, like we call the order processor calls, the customer subsystem. That's all part of one API. I've shown it as two different bubbles here, but it doesn't have to be. And it goes, hey, customer cache, give me the customer context for this customer, and it goes, I don't got it. That's when we got to fall back and call the customer API. And as part of that mechanism, we want to then stuff the customer context we get back into the API, from the API into the cache, rather. So, this is a typical way of kind of handling places where the domain is a little fuzzy and the other domain legitimately needs some, usually subset of the entity from that's owned by another domain. And the way you handle it is you put those objects into a shared context with, defined interfaces. You set up eventing on the repository, and you have a recovery you consider the recovery mechanism in case, for whatever reason, it gets out of sync. And in fact, it's not unusual for customer service to have a little tool that will cause it to read from the repository and generate a change event. In the case where a customer goes, oh, my about me page is wrong, or it's not it's not synchronized or whatever. And the other thing is, somewhere else we could have a preference or a configuration service that has, among other things, preferences, and one of the foreign keys to that is customer, and you want an abstraction there, and that's a useful thing to have. This is one of the ways that you can solve that. The other big problem that I run into increasingly frequently is this. This is a bad day in Architectureville. What this represents is a bunch of smart people in IT and the business sat down to describe the system. And as we did that, we started collecting entities, right? Sort of, you can see my other videos about kind of what the process is for turning requirements into domain-driven design. But fundamentally, you start identifying entities. So you identify order, and you identify customer, and you identify shipment, and blah, 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 blah. And then you start grouping those into domains, and you describe the interactions between the domains that are the result of a business use case or scenario, like new customer, new order, old customer, new order, old customer, not in cash, right? All those different, things. And you define what the system behavior should be, and then you do architecture, design, implementation to support that. But every once in a while when you finish, and typically, we tend to do this on a whiteboard. I like doing workshops in person. There's a lot of value to that. But you can even do it electronically. It's just slower and grumpier. But you end up with a big ball of mud. And it's painful because you go, wow, everything needs everything else. And that's what some of these circles are representing, right? That, you just have the things that you thought were domains, or even if each circle is an individual entity, that's even worse. If each circle is an individual entity and everything needs everything else, then wow, is it hard to tease these things apart. Now, you can do it artificially. You can implement a methodology like the one we put on the previous page, and it's kind of okay. But really, this is very grumpy making. And when this happens, you need to stop and have some thoughts. And the thoughts are called Plan B. So here's 3 Plan B strategies. Maybe you just don't have enough definition to make clean boundaries. Maybe if you had more information about this, or maybe if you looked at the entities and how they're grouped in and define different domains, then the circles wouldn't overlap as much. Because a little overlap between 2 circles is cool. That's the interface between the domains, and you do the usual things. You plunk APIs in there, and so on. And you say, okay, well then these things, the definition for these things needs to be in a shared context, like iCustomer. And it's your choice whether or not you want to just supply interfaces or supply interfaces in a shared model. Sometimes having a shared model makes the implementation a lot easier. A lot of that depends on the tooling. If I'm in C# in Visual Studio, I can right mouse click on an interface and say, make this, and it just does it. But there may be other subtle things in the model that you want, like model validation rules and things like that, that you might want to have part of your model. I tend to put validators for the state of the model itself, considering nothing external to the model in the model. And I tend to put validators for multi-model contexts, otherwise known as, a graph of different entity types. I tend to put those in their own validator. But the upshot is that it may be that what you need to do is look at all the entities from a different point of view and see if you can tease them out separately. sometimes you're just missing a set of dimensions, like you haven't thought about it. And by dimensions, I mean it the same way that data engineers and data modelers think of it, right? You have dimensions and you have facts. Dimensions are, the facts are the things in the cube, and the dimensions are all the radial axes of a multi-axial thing, and that allows you to control the data. And one of the things that's often implicit and understood to be there, but really not considered as a full-blown dimension that sometimes allows you to untangle all those circles. There are three of them that are really common that you should think about. One is time. You'd be surprised in how many systems, particularly like order systems or auditing systems or auction systems or trading systems, anything where the flow of time in very granularly is important. Sometimes adding time to the models allows you to spread those circles apart in ways that are more pleasing. The second dimension that's often ignored is idempotency. Fundamentally, underneath all these entities, is there a universal entity identifier that describes these entities? Call it a base class of some of these other things, like vendor, customer, employee, right? They all have a basis in person. They also have a basis in company. And you say, well, is there any scenarios in my system where a person doesn't have a company? It's easily solved by adding this is no company, right? So you can have those foreign keys or those hard business rules. And in that case, in the case of company, sometimes there's an external identifier out in the industrial space that's useful. Dun & Bradstreet numbers for corporate hierarchies are super handy. And Dun & Bradstreet covers a lot of scenarios in a lot of places in the world. But maybe there are, other equivalents, right? Maybe you have an identifier and an identifier type column, and together they define an idempotency space. And then once you have the idempotency space, you can redraw the circles in a new way where the intersections are the shared notion of idempotency, which could be an interface, which makes the connections between them shallow instead of deep, which is nice because deep connections have low cohesion and high coupling, and that's grumpy making. The third, dimension that I see omitted a lot is that some of these things may be represented by systems outside of yourself that you have no control over. And while those systems are essentially shared context in DDD, they're shared context with, I usually draw them bolded and, purple or something, right? Because the down and dirty of it is that if you are at the mercy of an external system to supply some of your key entities and entity relationships, they can't be external to the model. And so sometimes what happens is draw those around the outside, and when you end up with is a ring-shaped model, crosses in the center without that many overlaps. And that's sometimes better. So those are the three dimensions, right? Idempotency, external identifiers, and then maybe it really is one big domain where the entities and other objects are all much of a muchness. To quote Alice in Wonderland, I generally give, people 10 minutes to sulk. I call a bio break when we discover that. And then we sort of grind our teeth and go, okay, well, there isn't a nice teasing apart, right? We've done plan B, step A, and step B, and it just is one big thing. And so what we try to focus on is using solid to make to separate the entities and business logic and validators and all that other good stuff into nice pieces, even though they are probably going to run all together. And it just is what it is. Anyway, more about these things coming. My name is Stuart. Thank you for your kind attention.